So in this segment we are going to discuss about the Gini index. So first of all I'll discuss the definition of Gini index. After that I'll give some examples how to calculate Gini index. So first of all, as we can see, its definition is Gini index is an impurity based criteria that measures the divergence between the probability distribution of the target's attribute value. So so its formula is also given here, 1 minus summation of its relative frequency. This term is known as the relative frequency. So its formula is 1 minus summation of square of relative frequency. So next, as we have seen, this is the same formula, 1 minus summation of relative frequency square. So maximum value of the Gini index can be 1 minus 1 upon NC. This condition happens when the records are equally distributed among all the classes. So this result implies that the information is least interesting. Minimum value of the Gini index can be 0 when all the records belong to one class. So with the result of this we can imply that the information is most interesting. So we are going to discuss using some of the few examples here. So here's one example. Suppose we have two class C1 and C2. So to find the Gini index, we need to calculate firstly the relative frequency of C1. Relative frequency of C1 is equals to 0 upon 6. 6 is the summation of the both the values of C1 and C2. Then we have to calculate the relative frequency of the C2, that is 6 by 6 equals to 1. So as we know, the formula of Gini index is 1 minus summation of square of relative indexes. So we are calculating it 1 minus this is a PC1 is a relative frequency of the first class minus relative square of relative frequency of the second class. So it is 1 minus 1 is equals to 0. In the second example is same as the first. We have C1 is equals to 1, C2 has 5 records. So to find its relative frequency, it is 1 by 6. For C2 it's 5 by 6. To find its Gini value, we know the formula 1 minus summation of relative frequency square. That is, if we calculate it is 0.278. And third example is also same.